Hello, everybody. I hope you're doing well. Welcome back to another video for our Intro to Machine Learning workshop for the DSGT Udemy Bootcamp. So in the previous video, we've gone through another survey of models. So we've gone through the support vector machine and kind of got a conceptual intuition for it. So now what we're going to do is we're going to actually see the results, right? So we're going to plot our boundary, right? So this is a function here that's going to take your boundary and kind of do some plotting. And what this does is we're going to take each of the machine learning models we studied, so decision tree, logistic regression, neural network, SVM, and essentially plot the boundary to see how is our model classifying survived versus not survived, right? So we have these models, and we're going to plot boundary. So what we see here is the following, right? For the decision tree, we can see how well did our model kind of classify survive versus not survive. Logistic regression, this is what a neural network's doing. So you can see for logistic regression, it's kind of more linear. Decision tree is more like, boxy looking. Neural network, it's just a complicated looking entity. SVM, we have like that separator with the linear kernel, and the kernel SVM, we have like this curvature. So I think what you want to look at is kind of which one, well, number one, which one works best? So like in which scenario did the model do the best, right? At separating you know, the not survived from the survived. And I think the better question, which is very important in machine learning, is why? Like, what is the interpretable reason, right, for why the model did what it did, right? So I implore you to definitely look into these models and kind of do your research on them and try to see if you can have an intuitive reason, right, for why the models might behave the way they do. But this is how we can plot our results, and I think this would be very useful to better understanding your models. Okay, so now that we're able to have a visual depiction of how our model did, let's actually have some metrics that evaluate the performance of the machine learning models. So what are the metrics that you should use? Well, it depends for regression versus classification. So in regression, mean squared error and R squared are like pretty good metrics to start off with. For classification, accuracy, precision, recall, and something called the confusion matrix is very good. Now, the one thing you need to be careful about is accuracy is not the end all be all metric, right? Accuracy is just not a good metric when we have imbalanced data, right? So if you have a scenario where the classes aren't represented equally, accuracy is not a good representation, right? Because what is accuracy? It's the total number of correct over the total, right? So if you're having more examples of certain labels but less of certain of other labels, you could be getting like a 99% accuracy, but that's because your data set was very imbalanced, right? So you want to be careful about things like that, right? So that's why accuracy is not a good metric in that case. And there are metrics that you can generate from the confusion matrix that can give you the better story, right? So here's an example with imbalanced data, right? So we have a data set where 90% of the data is labeled as 0 and 10% are labeled as 1, right? So we see here we get a imbalanced data set right here, right? So I guess one thing is the imbalance really this statistic? And also, like, can we come up with a simple model that will just have a very high accuracy, right? So I implore you to think about this. So yes, totally you can have this kind of imbalanced data like this drastic. And yes, you can come up with simple models that have a very high accuracy, but like for example, you can get a model that optimizes on predicting 0 correctly, but then all the ones wrong, right? So you get 90% accuracy. You could do things like that, right? So here's an example where you can simply predict 0 for all the data, right? And essentially by taking a classification report for, your ground truth for the y versus your predicted, you see here we've got a 90% accuracy just by predicting 0, right? So this is a flaw with accuracy, right? So if I give you this evaluation table, is just predicting 0, like, if I just give you this evaluation like report and I tell you we got a 90% accuracy, like what should you think, right? I mean, it's just a number at the end of the day, and you have to kind of understand the whole story, right? So that's a basic understanding of evaluation metrics and the power of visualization in machine learning modeling to understand how your model is performing. In the next video, we're going to be performing statistical evaluation to see how well our machine learning models did on a Titanic dataset. So see you in the next video.